Hello everyone, welcome back. In the previous video we completed the roller mounting and tensioning arrangement. Now it's time to design the most important roller in the conveyor system, the drive roller, which drives the conveyor. So in today's video we will understand the drive roller, fundamental difference between the carrying roller and the drive roller, and solid drive roller construction, and the bearing consideration. So let's begin. First of all, what is the drive roller? Is the important. So the drive roller is powered roller connected to the motor and the gearbox. Its main function is to transfer the torque to the conveyor belt. As the roller rotates, the friction between the roller surface and belt causes belt to move. So without sufficient friction, the belt will slip, obviously. So this is why the drive roller design is extremely important. Now if we discuss about the carrying roller and the drive roller difference, so carrying rollers means we will design later the idler roller and the driven roller, we can say. So they supports the idler roller is supports the belt, rotates freely. There is no power transmission, there is lower the load. But the drive roller is connected directly to the motor, so it transmits the torque, higher loading, and we can say it requires stronger mounting than the driven or any other rollers. Okay, so first we will make the drive roller, then we will use the idler roller similar to the driven roller. So let's start. Go to the file and make a part. Here we are considering the bearings, that we will mount the bearing at the external part of the roller. So first go to the front plane, create the sketch. Now this is the main body of the roller, this will be the bearing part. Okay, let's just draw the roller, then we will remove if we don't want anything. Okay, first of all, this roller will be directly connected to the motor gearbox. So let's make the dimensions. It's 200, I think. Roller diameter was, I think, 40 mm, so it's a 20. I think we should remove this one. Okay, now this one will be connected to the motor, so this will be quite bigger in a size. Let's say it's 60 for now, we will change it later. And this side will be on the bearing, so we will consider as 40 mm. We can change the dimensions, that's why I am just putting the values approximately. Okay, just let's take a 7 because sometimes the 14 diameter is standard. We will check this also in the next video, how to select the bearing and which bearing is suitable for this RPM and the load. And one more important thing is the motor and the gearbox selection for the any conveyor system. So we will do that later in the upcoming videos. I hope you are doing well, you are practicing something, you are learning something. Okay, something is wrong. Okay, I think we should close this and directly see how it is. Okay, it's working. Let's check our driven roller size. So friends, whatever the diameter we have chosen, it's a 40, and for the dry roller also we will use 40 diameter, and the length will be the same because okay, what was the length was bigger than 200, so 224. So let's quickly change this 224, and okay, I think we need to have any maybe changes sometimes, because the bearing sizes and the gearbox sizes are need to be chosen from the standards. So this is the dry roller. Let's save this. Okay, now this is simple dry roller. We will add the fillet for this because fillet is important when you design the any cylindrical part which has a torque. Then the torsional stress will be there. So at this point sometimes there are chances to break this at this point because of more torsional stresses induced in this. Because of the torque, we are transferring the torque from this side to this side, and this is a solid roller, so the mass of this roller at the center is bigger than the side of this roller. Okay, so this is the basic. Okay, let's save this. We will add this roller to the assembly. We have to design our exit bracket for this, but I think we need to, we will design the exit bracket in the next video, and after that we will decide the bearings which will be mounted on the both sides, and what will be the housing and the motor and gearbox selection, so that our conveyor the basic structure will be complete, and then we can calculate the other things which are maybe required in the future for better understanding. Because we are not only assembling the conveyor, we will understand why this is taken as a 40 and what was the torque and how the material will flow from this, and maybe some formulas which required to design a conveyor mechanism. Okay, so thanks for watching. See you in the next video.